Hello, curious minds, and welcome back to our channel. Today, we're diving into a ubiquitous, yet often underestimated marvel of the digital age, the QR code. You see them everywhere, on product packaging, restaurant menus, advertisements, and even as your boarding pass. These seemingly simple black and white squares hold a fascinating story of innovation, efficiency, and a profound impact on how we interact with information. But have you ever stopped to wonder, what exactly is a QR code? How does it work? And who brought this ingenious invention into existence? Prepare to embark on a journey that decodes the very essence of these powerful little squares. The dawn of digital recognition, unveiling the enigma. Before the QR code, the world of automated identification was largely dominated by the barcode. Linear, one-dimensional, and capable of holding only a limited amount of data, barcodes were revolutionary in their time, streamlining inventory management and retail transactions. Think of scanning a grocery item. That's the barcode at work. However, as the digital landscape expanded and the demand for richer, more complex information grew, the limitations of the traditional barcode became increasingly apparent. Businesses needed a way to store more data, to link physical objects to digital content, and to do so with speed and reliability. This burgeoning need for enhanced data capacity and faster readability laid the groundwork for a new kind of visual code, one that could transcend the boundaries of its predecessor. The stage was set for an innovation that would forever alter the way we bridge the physical and digital realms, paving the way for the sleek, data-rich squares we now recognize as QR codes. The fundamental principle behind the QR code, much like the barcode, lies in optics and pattern recognition. When you scan a QR code with your smartphone, the device's camera captures an image of the square. Sophisticated algorithms then analyze this image, identifying the unique patterns within the code. Unlike linear barcodes that store data in varying widths of parallel lines, QR codes are two-dimensional, meaning they store information both horizontally and vertically. This spatial arrangement dramatically increases their data storage capacity. Imagine a tiny digital labyrinth where each black or white square, known as a module, represents a bit of data. The arrangement of these modules forms a precise pattern that, when decoded, reveals the embedded information. This two-dimensional nature is the key to their power, allowing them to encode everything from website URLs to complex text strings, contact information, and even entire Wi-Fi network credentials, all within a compact and scannable format. This ingenious design marked a significant leap forward in the science of automated identification. The initial development of the QR code was driven by a very specific and pressing industrial need, which we'll explore in detail in our next chapter. However, its eventual widespread adoption speaks volumes about its inherent advantages. Its robust error correction capabilities, for instance, mean that even if a portion of the code is damaged or obscured, it can often still be scanned successfully. This is a testament to the meticulous engineering behind its design, incorporating mathematical principles that allow for redundancy and data reconstruction. Furthermore, the speed at which QR codes can be read, often within milliseconds, made them incredibly appealing for applications where efficiency was paramount. This combination of high data capacity, robust error correction, and rapid readability made the QR code a truly transformative technology. Its unassuming appearance belies the complex algorithms and sophisticated design principles that make it such a powerful tool in our increasingly interconnected world, a true testament to human ingenuity in solving real-world problems with elegant solutions. Denso wave and the automotive revolution. The birth of a vision. Our journey now takes us to the early 1990s, specifically to Japan, and into the heart of the automotive industry. This is where the story of the QR code truly begins, not in a futuristic tech lab, but on the bustling, highly demanding factory floors of an automotive parts manufacturer. The company at the forefront of this innovation was Denso Wave, a subsidiary of the global automotive components giant, Denso. At this time, the automotive industry was grappling with an immense logistical challenge, tracking thousands of different parts and components during the manufacturing process. Traditional barcodes, while useful, simply couldn't keep up with the sheer volume and complexity of information required. Imagine an assembly line needing to identify specific engine components, electrical systems, and interior parts, all moving at a rapid pace. The limitations of one-dimensional barcodes meant slower scanning times, limited data storage per code, and a bottleneck in the overall efficiency of the production line. This was a critical pain point that demanded a revolutionary solution. Masahiro Hara, an engineer at Denso Wave, was tasked with finding a better way. His challenge was to develop a two-dimensional code that could store significantly more information than a traditional barcode, and crucially, could be scanned much faster. The goal was to improve inventory management, streamline logistics, and reduce errors in manufacturing. Hara's team wasn't just looking for an incremental improvement. They needed a paradigm shift in automated identification. The existing barcodes often required precise alignment with a scanner, which was time-consuming and prone to errors in a fast-paced environment. The vision was to create a code that could be scanned from any direction, at speed, and with high reliability, even if partially obscured or damaged. This ambitious goal was the catalyst for the invention of the QR code. The QR itself stands for Quick Response, a direct reflection of this primary objective: speed and efficiency in data retrieval. The genius of Hara's design lay in its elegant simplicity and robust functionality. One of the most distinctive features of a QR code is its three large corner squares. These are known as finder patterns, and they are crucial for rapid and omnidirectional readability. When a scanner reads a QR code, it first identifies these three patterns, which immediately orient the code, regardless of its angle. This means you don't have to carefully align your smartphone perfectly to scan a QR code, unlike the more finicky traditional barcodes. This seemingly minor detail was a monumental breakthrough for industrial applications, drastically reducing scanning time and improving operational efficiency. The fourth, smaller square, called the alignment pattern, helps to correct for distortion and curvature, further enhancing readability, especially when codes are printed on uneven surfaces. These patterns are not just aesthetic. They are fundamental to the scientific principles that make QR codes so effective. The development process involved extensive research into mathematical algorithms for data encoding and error correction. Hara and his team had to ensure that the code could withstand minor damage or smudging and still be perfectly scannable. This led to the incorporation of Reed-Solomon error correction, a sophisticated mathematical technique also used in technologies like CDs and DVDs. This error correction capability allows a QR code to be readable even if up to 30% of its surface is damaged, depending on the error correction level chosen during generation. This resilience was absolutely vital for the harsh conditions of a factory floor, where codes could easily get dirty or scratched. In 1994, after years of dedicated work and innovative engineering, Denso Wave officially released the QR code to the public. While initially conceived for industrial purposes, its potential for broader applications soon became apparent, setting the stage for its eventual explosion into consumer markets worldwide. The invention was a triumph of applied science, solving a real-world problem with an elegant and enduring solution. Anatomy of a square. Decoding the visual language. Let's get up close and personal with the anatomy of a QR code. While they might appear as simple black and white mosaics, each element within that square serves a specific and crucial function. akin to a microscopic city plan where every building has a purpose. Understanding these components isn't just an academic exercise. It reveals the scientific ingenuity that makes QR codes so efficient and robust. At its most fundamental level, a QR code is composed of individual squares called modules. These modules are either black or white, representing binary data, a 0 or a 1. The arrangement of thousands of these modules forms the unique pattern that encodes information. But there's a highly structured layout to this seemingly random jumble, ensuring that scanners can quickly and accurately interpret the data. As we discussed, the most prominent features are the three large finder patterns located at the corners of the code, excluding the bottom right. These are absolutely critical for rapid orientation. Imagine your smartphone camera taking a picture of a QR code. The first thing its decoding software does is locate these three squares. Their distinctive bullseye appearance, a large black square surrounded by a white square, then another black square, provides a robust reference point. Regardless of the angle or rotation of the QR code, these patterns allow the scanner to instantly determine the code's orientation and boundaries. This omnidirectional readability is a key differentiator from traditional barcodes, which typically require a specific alignment. Without these finder patterns, scanning would be a far slower and more frustrating experience, especially in real-world scenarios where precise positioning isn't always feasible. They are the lighthouses guiding the scanner through the sea of data. Along with the finder patterns, you'll find other crucial positioning elements. There's a single, smaller alignment pattern, usually located near the bottom right finder pattern, in larger QR codes. This pattern helps to correct for any distortion or perspective changes that might occur if the code is printed on a curved surface or scanned from an awkward angle. It's a sophisticated method of geometric correction, ensuring that the data grid remains accurate even under less than ideal viewing conditions. Running between the finder patterns are timing patterns, alternating black and white modules that help the scanner determine the exact size of each module and the overall grid structure. Think of them as rulers embedded within the code, allowing the decoding software to calibrate itself and accurately extract information from the data modules. These timing patterns are essential for maintaining the integrity of the data grid, especially in varying print qualities or resolutions. The remaining areas of the QR code are dedicated to storing the actual data and, importantly, error correction information. The data modules themselves carry the encoded information, be it a URL, text, or contact details. Interspersed with this data are error correction modules. This is where the magic of Reed-Solomon error correction comes into play. When a QR code is generated, a certain percentage of its modules are dedicated to storing redundant information. This redundancy allows the code to be reconstructed, even if some parts are damaged, dirty, or obscured. There are 4 levels of error correction, from L, low, 7% restorability, to H, high, 30% restorability. Choosing a higher error correction level means more modules are dedicated to redundancy, resulting in a larger, more complex code, but also a more resilient one. This incredible self-repairing capability is a cornerstone of the QR code's reliability and why it has been so widely adopted in diverse environments, from pristine offices to rugged industrial settings. It's a brilliant application of mathematics, ensuring robust data integrity. The science of readability. How scanners see data. Have you ever wondered about the intricate ballet of light and algorithms that occurs the moment your smartphone camera locks onto a QR code? It's far more sophisticated than simply taking a picture. The process involves a complex interplay of optics, digital signal processing, and advanced pattern recognition, transforming a visual pattern into actionable data in a fraction of a second. When you point your camera at a QR code, The device's image sensor captures light information, converting it into a grid of pixels. Each pixel records color and intensity data. For a black and white QR code, this means identifying areas of high light absorption, black modules, and high light reflection, white modules. This raw visual data is then fed into the smartphone's processor, initiating the decoding sequence. The first critical step for the decoding software is to locate and orient the QR code within the camera's field of view. This is where the finder patterns, those three prominent squares, come into play. The software is specifically programmed to look for the unique bullseye shape of these patterns. It identifies their positions and uses them to determine the code's boundaries and its angle of rotation. This ability to instantly orient the code from any perspective is a major scientific advantage, drastically speeding up the scanning process. Without these robust reference points, the software would have to perform more extensive image analysis, which would be computationally intensive and much slower. Once the finder patterns are located, the software can then establish a virtual grid over the entire QR code, accurately mapping where each module should be. This grid is essential for precisely isolating each individual black or white square. With the grid established, the software proceeds to analyze each module within the identified QR code area. It determines whether each module is predominantly black or white. This is typically done by comparing the average pixel intensity within each module to a threshold. Modules below the threshold are classified as black, representing a 1 in binary, and modules above it are classified as white, representing a 0. This conversion of visual input into binary data is the core of the decoding process. Simultaneously, the alignment pattern and timing patterns are utilized to correct for any perspective distortion or physical warping of the code. If the code is printed on a curved surface, for example, the alignment pattern helps the software mathematically flatten the image of the code, ensuring that the grid of modules is interpreted accurately, preventing errors that could arise from skewed data points.
Once the entire QR code has been converted into a stream of binary data, the final and perhaps most impressive scientific step occurs: error correction and data extraction. The Reed-Solomon error correction algorithms come into play here. The software checks for consistency and uses the redundant information embedded within the code to identify and correct any errors that might have occurred due to damage, dirt, or poor print quality. This means that even if a portion of the code is unreadable, the decoder can often reconstruct the missing data, ensuring a successful scan. After all errors are corrected, the binary data is then translated back into a human-readable format, such as a URL, a text message, or contact information. This translated information is then presented to the user, typically by opening a web browser, composing an email, or adding a contact. This entire complex sequence, from light capture to data presentation, happens in the blink of an eye, a testament to the incredible advancements in digital imaging and computational science that make QR codes an indispensable tool in our daily lives. Beyond URLs, diverse applications of QR technology. Initially conceived for streamlining manufacturing logistics, the QR code has, over the past decade, transcended its industrial origins to become a versatile tool embedded in almost every facet of our modern lives. Its ability to quickly bridge the physical and digital worlds has unlocked an astonishing array of applications, far beyond simply linking to a website. One of the most widespread and immediately impactful uses is in touchless information access. Consider restaurant menus. Once a staple of physical paper, many establishments now offer QR codes at tables, allowing diners to scan and access a digital menu on their smartphones. This not only offers convenience and reduces paper waste, but also provides a more hygienic solution, particularly in the wake of global health concerns. Similarly,
Museums and art galleries use QR codes to provide visitors with extended information about exhibits, historical context, or artist biographies, enhancing the educational experience without the need for bulky guidebooks. The realm of marketing and advertising has been utterly transformed by QR codes. Advertisers can embed QR codes in print ads, billboards, and even television commercials, offering consumers an immediate pathway to engage with their brand. Scanning a code might lead to a promotional video, a special discount offer, a product demonstration, or a direct link to an e-commerce store. This allows for measurable engagement, providing valuable analytics on how consumers interact with campaigns. For example, a car advertisement with a QR code could take you directly to a virtual test drive experience or allow you to schedule a real one with a local dealership. This dynamic interaction makes advertising more effective and user-centric, moving beyond passive consumption to active engagement, collecting real-time data about customer preferences and behavior, which is invaluable for refining future marketing strategies and understanding consumer trends in an increasingly digital marketplace. The ability to track scans provides a direct metric for campaign success. Beyond marketing, QR codes have made significant inroads into the payment processing sector, especially in regions like China, where mobile payments are dominant. By scanning a QR code displayed by a merchant, users can instantly transfer funds from their digital wallets, making transactions seamless and secure. This system reduces the need for physical cash or credit cards, offering convenience and efficiency for both consumers and businesses. Think of a street vendor or a small business. A QR code payment system is often far more accessible and cheaper to implement than traditional card readers. Similarly, ticketing has seen a major overhaul. Concert tickets, airline boarding passes, and movie tickets are increasingly delivered as QR codes, stored securely on smartphones. This not only reduces paper waste, but also speeds up entry processes, as scanners can quickly validate the digital codes, improving the overall customer experience and reducing queuing times at venues. The utility of QR codes extends to critical areas like product authentication and supply chain management. Manufacturers can embed unique QR codes on their products, allowing consumers to scan them and verify authenticity, combating counterfeiting. This is particularly crucial for high-value goods like pharmaceuticals or luxury items. In supply chains, QR codes enable granular tracking of products from origin to destination, providing transparency and efficiency. Logistics companies can quickly scan codes on packages to update their location, manage inventory, and ensure timely delivery, leading to significant operational improvements. Even in personal use, QR codes are incredibly convenient for sharing Wi-Fi network credentials, contact information, or even linking to digital resumes. The ability to encode a wide variety of data types, combined with their rapid readability and robust error correction, has cemented the QR code status as a fundamental building block of our connected world, continuously adapting to new challenges and opportunities presented by technological advancements. QR codes in education and information sharing. The advent of the QR code has brought about a quiet revolution in the realm of education and information sharing, transforming how knowledge is accessed, disseminated, and engaged with. Moving beyond the static pages of textbooks and the confines of traditional classrooms, QR codes offer dynamic pathways to richer, more interactive learning experiences. Imagine a student scanning a QR code next to a diagram in their biology textbook, instantly being transported to an animated 3D model of the human heart, complete with detailed physiological explanations and interactive labels. This immediate access to multimedia content can significantly enhance understanding, catering to diverse learning styles and providing a depth of information that printed materials simply cannot match. It bridges the gap between theoretical knowledge and practical visualization, making complex subjects more digestible and engaging for learners of all ages. In museums and historical sites, QR codes have become invaluable tools for enriching the visitor experience. Instead of relying on crowded information plaques or audio guides, visitors can scan codes next to artifacts or exhibits to access supplementary content directly on their smartphones. This might include historical documentaries, expert interviews, interactive timelines, or even augmented reality experiences that bring ancient civilizations to life. This personalized approach allows individuals to delve deeper into topics that genuinely interest them, tailoring their educational journey through the exhibit. For example, scanning a code next to a dinosaur skeleton could lead to a video explaining its discovery, habitat, and scientific significance, creating a multi-layered learning experience that goes far beyond a simple text description, captivating younger audiences and academic researchers alike, extending the educational reach of the institution. Furthermore, educators are leveraging QR codes to create more interactive and engaging classroom environments. Teachers can embed QR codes in worksheets, presentations, or even around the classroom itself. Scanning these codes could lead students to online quizzes, supplementary reading materials, vocabulary lists, instructional videos, or even collaborative online discussion forums. This facilitates flipped classroom models, where students can access lecture content or preparatory materials outside of class, freeing up valuable class time for discussions, problem solving, and hands-on activities. It encourages independent learning and provides immediate feedback, allowing students to learn at their own pace and revisit complex topics as needed. The low cost and ease of generation make QR codes an accessible technology for even resource-constrained educational institutions. The power of QR codes in information sharing extends beyond formal education into everyday knowledge dissemination. Public libraries use QR codes to link physical books to online reviews, author interviews, or related literary works, fostering a deeper connection with the content. Community centers and public service organizations use them to provide easy access to essential information, such as health advisories, emergency contact details, or schedules for local events. For individuals, QR codes offer a simple way to share Wi-Fi credentials with guests, quickly link to an online portfolio, or even provide digital instructions for household appliances. This ability to instantly deliver a wealth of digital information from a physical point of interaction has made QR codes an indispensable tool for democratizing knowledge and making information more accessible and engaging across a wide spectrum of applications, enhancing our collective ability to learn and share in the digital age. Security and privacy considerations. The digital gateway's guardrails. While QR codes offer unparalleled convenience and efficiency, it's crucial to address the security and privacy considerations that accompany their widespread use. Just like any digital gateway, QR codes can, unfortunately, be exploited by malicious actors if users are not vigilant. The primary concern revolves around QRishing, a portmanteau of QR and phishing. This occurs when a deceptive QR code leads users to malicious websites designed to steal personal information, install malware, or compromise their devices. Imagine scanning a QR code on what appears to be a legitimate advertisement, only to be redirected to a fake banking login page that captures your credentials. Since the destination of a QR code isn't immediately visible, users are inherently trusting the source, which can be a significant vulnerability if that source is compromised or outright malicious. The anonymity of a QR code's destination makes it a potent tool for cybercriminals. They can easily print fake QR codes and paste them over legitimate ones in public places, such as bus stops, ATMs, or even payment terminals. These fraudulent codes often direct users to phishing sites that mimic legitimate services, asking for sensitive data like usernames, passwords, credit card numbers, or social security details. Once this information is entered,
it falls directly into the hands of the attackers. Another vector of attack involves malware. A malicious QR code could potentially lead to a website that automatically downloads and installs harmful software onto your device without your explicit consent. This malware could then spy on your activities, steal data, or even lock your device for ransom. The scientific design of the QR code itself is secure. The vulnerability lies in the content it links to and the trust users place in unknown codes. So, how can you protect yourself? The first and most important rule is to be discerning about where you scan QR codes. If a QR code appears in an unexpected or suspicious location, or if it seems to cover an existing code, exercise extreme caution. Always inspect the URL that appears after scanning before proceeding to the linked website. Most modern smartphone QR scanners will display the destination URL, giving you a chance to verify its legitimacy. Look for familiar domain names and HTTPS encryption, signified by a padlock icon, in the URL, indicating a secure connection. If the URL looks strange or generic, it's best to avoid it. Using a reputable QR code scanner app that offers built-in security features, such as URL scanning and threat detection, can also add an extra layer of protection, alerting you to potentially dangerous links before you click them.
Furthermore, be mindful of the permissions you grant to apps that use QR codes. Only download apps from official app stores and scrutinize the permissions they request. A QR code scanner app generally doesn't need access to your contacts or microphone, for example. In enterprise settings, organizations must implement robust security protocols, including regular auditing of publicly displayed QR codes and educating employees and customers about potential threats. While the technology behind QR codes is inherently secure and efficient in linking data, the responsibility for safe usage ultimately rests with the user and the organizations deploying them. By understanding the potential risks and adopting best practices for safe scanning, we can continue to leverage the incredible benefits of QR codes while safeguarding our digital security and privacy in an increasingly interconnected world. The future of QR codes, augmented reality, and beyond. As technology continues its relentless march forward, the humble QR code is evolving right alongside it, finding new and innovative ways to integrate into emerging digital landscapes. Far from being a relic of the past, QR codes are poised to play an even more significant role in the future, particularly in the burgeoning fields of augmented reality, the Internet of Things, and personalized digital experiences. Imagine a world where scanning a QR code doesn't just take you to a website, but instead triggers an immersive AR experience directly overlaid onto your physical environment. This is not science fiction. It's already beginning to happen. For example, furniture retailers are using QR codes that, when scanned, allow you to visualize a 3D model of a sofa placed virtually in your living room, helping you make informed purchasing decisions. In smart cities and urban environments, QR codes are becoming integral to navigation and information access. Imagine walking through a city park and scanning a QR code on a sign to instantly see an AR overlay of the park's history, local flora and fauna, or real-time event schedules. This provides a dynamic, location-aware information layer that enhances the urban experience. Public transportation hubs could use QR codes to provide real-time updates on train or bus schedules via AR, helping commuters navigate complex routes more efficiently. The potential extends to maintenance and infrastructure. Engineers could scan QR codes on public utilities to access schematics, repair histories, and diagnostic information in an AR overlay, streamlining fieldwork and improving response times. The ability of QR codes to precisely anchor digital information to physical points makes them ideal for AR applications. The Internet of Things, IoT, is another frontier where QR codes are finding new purpose. As more everyday objects become smart and connected, QR codes can serve as a simple, intuitive interface for interacting with them. Scanning a QR code on a smart appliance could instantly connect it to your home Wi-Fi network, register the device, or access its digital manual. In industrial IoT settings, maintenance technicians could scan QR codes on machinery to access real-time performance data, maintenance logs, and troubleshooting guides, enhancing predictive maintenance and operational efficiency. The seamless integration of physical objects with their digital twins via a simple scan transforms how we interact with our environment, making complex technologies more user-friendly and accessible, pushing the boundaries of what is possible with connected devices and intelligent systems, reducing friction in our digital interactions. Beyond AR and IoT, QR codes are likely to see increased personalization and adaptive functionality. Imagine a QR code on a product that, when scanned, delivers tailored information based on your purchasing history or expressed preferences. Future iterations could even dynamically change the information they encode based on external factors like time of day, location, or even the identity of the scanner, with appropriate privacy safeguards. This adaptability opens up possibilities for highly personalized marketing, context-aware information delivery, and more intelligent interaction with our surroundings. While other technologies like NFC, near-field communication, offer similar functionalities, the ubiquity of smartphone cameras and the visual nature of QR codes ensure their continued relevance. Their scientific robustness, coupled with ongoing innovation, guarantees that QR codes will remain a cornerstone of our increasingly connected and intelligent future, constantly evolving to meet the demands of an ever-changing digital world. Comparison with other technologies, the unique niche of QR codes. In the vast landscape of automated identification technologies, the QR code doesn't stand alone. It coexists and often complements other powerful systems like traditional linear barcodes, near-field communication, NFC, and radio frequency identification, RFID. Understanding the unique niche and advantages of QR codes often requires a comparative analysis of these different technologies. Let's start with the most obvious predecessor, the linear barcode. Barcodes, like the ubiquitous UPC, Universal Product Code, found on retail items, are one-dimensional, storing data horizontally in varying widths of parallel lines. They are excellent for identifying products with a unique numerical ID, but their data capacity is very limited, typically around 20 to 25 characters. QR codes, being two-dimensional, can store significantly more data, up to 7,089 numeric characters, or 4,296 alphanumeric characters. This difference in data capacity is a primary reason why QR codes excel in applications requiring richer information, like website URLs or contact details, while barcodes remain dominant for basic product identification in retail. Next, let's consider near-field communication, NFC. NFC is a short-range wireless technology that allows two devices to communicate when they are brought within a few centimeters of each other. Think of tapping your smartphone to a payment terminal or pairing Bluetooth headphones. NFC tags are typically small, passive chips that can store a modest amount of data and are powered by the electromagnetic field of the scanning device. The key advantages of NFC are its instant connection, no need for a camera or app opening, and its inherent security for certain applications due to the extremely short range. However, NFC requires specialized hardware, an NFC reader or an NFC-enabled phone, in both the tag and the reading device. QR codes, on the other hand, only require a standard camera and decoding software, which are almost universally present in modern smartphones. While NFC is excellent for secure, quick transactions or device pairing, QR codes offer greater versatility for widespread, information-rich dissemination,
where a longer scan distance and visual interface are beneficial.
Then there's radio frequency identification, RFID. RFID systems consist of a tag containing an antenna and a microchip and a reader. Tags can be passive, powered by the reader's radio waves, or active, with their own power source, allowing for longer read ranges. RFID is highly effective for inventory management, asset tracking, and supply chain logistics, especially when reading multiple tags simultaneously without line of sight. Imagine scanning an entire pallet of goods at once. The advantages of RFID include rapid bulk scanning and the ability to read tags through packaging. However, RFID systems typically involve higher hardware costs for both tags and readers, and the tags are not visually readable by humans. QR codes are a visually readable, low-cost, and easy-to-generate solution that can be printed on virtually any surface. While RFID excels in complex, large-scale automated tracking, QR codes offer a simpler, more universally accessible solution for bridging physical objects with digital information, particularly for consumer-facing interactions where cost and ease of implementation are paramount. In essence, each technology serves a distinct purpose. Barcodes are for basic identification, NFC for secure, close-range interaction, and RFID for large-scale automated tracking. The QR code carves its unique niche as a bridge between the physical and digital worlds, offering high data capacity, rapid omnidirectional scanning, and universal accessibility via smartphone cameras. Its low cost of implementation, combined with its robust error correction and versatility, makes it an ideal solution for a vast array of consumer and public information applications where visual recognition and easy access to digital content are key. While other technologies may be more specialized for certain industrial tasks, the QR code's blend of features ensures its continued relevance as a truly general-purpose digital conduit, making it an indispensable component of our digitally integrated lives. Generating your own QR codes. Empowerment through creation. Now that we've explored the fascinating history, intricate anatomy, and diverse applications of QR codes, it's time to unlock the power of creation. One of the most remarkable aspects of QR technology is its accessibility. Anyone can generate a QR code with minimal effort, linking their physical world to digital information. The process is surprisingly straightforward, thanks to numerous free online QR code generators. These tools harness the same scientific principles we've discussed, encoding your desired data into the visual pattern of a QR code. Whether you want to share your website, Wi-Fi password, contact information, or even a simple text message, generating a QR code empowers you to disseminate information quickly and efficiently. The first step is to choose your desired data type. Most QR code generators offer a range of options, including URL/website, the most common use, directing scanners to a specific web page. Text encodes a short message, which appears on the scanner's screen. Contact information, vCard, allows you to share your name, phone number, email, and address, making it easy for others to add you to their contacts. Email address pre-populates an email with a recipient and subject line. Phone number initiates a call to a specific number. SMS message creates a pre-written text message to a specific number. Wi-Fi network automatically connects devices to a Wi-Fi network, requiring the network name, SSID, and password. Location, Google Maps, opens a map application to a specific geographic coordinate. Once you've selected the data type, you'll simply input the relevant information into the generator's fields. For a URL, you'd paste the website address. For a vCard, you'd fill in your contact details. The generator then processes this input, applying the algorithms for data encoding and error correction. Next, you'll often have the option to customize your QR code. While the core black and white modules are essential for readability, Many generators allow you to choose different error correction levels, L, M, Q, H. Remember, a higher error correction level makes the code more resilient to damage, but also makes it physically larger and more complex. For most general uses, a medium error correction level is sufficient. Some generators also offer stylistic customizations, such as changing the color of the modules or adding a logo in the center. While these can make your QR code visually appealing, it's crucial to ensure that any design modifications do not compromise readability. Always test your custom codes with multiple scanner apps and devices to confirm they function correctly across various platforms and conditions before deploying them publicly. Finally, after generating your QR code, you'll download it as an image file, typically PNG, JPG, or SVG. You can then print this image on business cards, posters, flyers, or display it digitally on screens. Before widespread use, always perform a test scan with your smartphone and ideally a few other devices to ensure the code works as intended. This simple act of creation connects you directly to the scientific principles of data encoding and visual communication. From facilitating touchless menus to sharing personal information, generating your own QR codes empowers you to efficiently share digital content, bridging the gap between the physical and virtual worlds with a simple scan. This accessibility is a testament to the brilliant engineering of Masahiro Hara and Denso Wave, making complex technology a tool for everyone. And there you have it, the incredible journey of the QR code, from its origins in Japanese automotive factories to its ubiquitous presence in our pockets and public spaces today. This unassuming black and white square is a testament to ingenious engineering solving complex problems with elegant, efficient solutions. From streamlining supply chains to transforming how we access information, pay for goods, and even experience art, QR codes have undeniably shaped our digital landscape. They are a powerful reminder of how a seemingly simple invention, rooted in robust scientific principles, can profoundly impact our daily lives. So the next time you scan a QR code, take a moment to appreciate the quick response and the fascinating science behind this modern marvel. Thank you for joining us on this exploration, and we'll see you in the next video.